Hey guys, this is the Leetcode problem 509 Fibonacci number, and let's just get right into it. And I'm gonna read the description. This is an easy problem, by the way. The Fibonacci numbers, commonly denoted f of n, form of a sequence called the Fibonacci sequence, such that each number is the sum of the two preceding ones, starting from 0 and 1. That is, Fibonacci of 0 is always 0, Fibonacci of 1 is always 1. So remember that this is always going to be true. And Fibonacci of n is always going to be Fibonacci of n minus 1 plus Fibonacci n minus 2 for any number greater than 1. And yeah, this is the basic logic behind the Fibonacci sequence. Like, it's the sum of the two preceding ones. So yeah, it gives us a couple of examples here. We have with the input of, like, this is the input, just n as an integer, 2. 2 is going to be Fibonacci of 2, which is Fibonacci of 1 plus Fibonacci of 0. We know that Fibonacci of 1 is always 1 and Fibonacci of 0 is always 0. So 1 plus 0, 1. In the second example, we have and 3, and the output is 2 because Fibonacci of 3 is just Fibonacci of 2 plus Fibonacci of 1. We know that Fibonacci of 2 is Fibonacci of 1 plus 0, which is 1 plus 0, which is 1. So it's 1. If Fibonacci of 1 is always going to be 1. So 1 plus 1, 2. And the same thing goes here, like, and keeps going on and on and on and on, and that's the Fibonacci sequence. So you can kind of see that that's kind of a pattern going on here. So we're always gonna reuse some of the some parts of the sequence, like Fibonacci of 4. See that we're trying to use here Fibonacci of 3 and Fibonacci of 2. And in Fibonacci of 3, we also are trying to get Fibonacci of 2 and Fibonacci of 1. So in, in theory, like, we need to go all the way down to Fibonacci of 1 and 0 to get, like, the actual values, like 1 and 0, for example. And if we, like, there's like optimal ways of doing that. If we kind of store, like, let's say if here we stored the value of Fibonacci of 3, we would know, like, that this is 2 already, and if we have stored this here, we would know that this is 1. So we would already have the values here, like 2 plus 1, and this would be even faster. But this kind of pattern here, and this thing of reutilization of the sequence is kind of a concept of dynamic programming and recursion. So we want to use recursion to generate a solution for that. So let's just say that, given this premises here, let's just add two comments here just for the sake of understanding the sequence. And we know that Fibonacci of 0 and Fibonacci of 1 are going to give us real numbers, like 0 and 1. So we could just start that by saying if n uh, equals 0, we just return n. Like, this is the Fibonacci function, right? So if we want to get the first value of the the zeroth value of the sequence, it's going to be 0. So it's going to return itself. It's going to return 0 here. The same goes for 1. So if we do Fibonacci, if n is 1, we want to know the Fibonacci number in the first position, like in the second, actually, the 1th position. This is going to be 1. So we could do that, like, in another way, like, just to save lines here. If n is greater than or equal to 1, which means like 1 or 0, we return n. So if it's 1, it's going to return 1, and if it's 0, it's going to return 0. And we know that this is the kind of the Fibonacci function for getting the actual value for the position. So to kind of reuse this function here, one way to do this is, I think this looks better. We could just call itself, we could say that I is like the first Like we needed two preceding numbers. So the first preceding number, let's say this is I, is gonna call uh, the, the the actual function itself. Like we're in this function, but we're gonna call itself again with the value n minus one, right? Because this is the previous element, and we want the two preceding elements. And let's say j is going to be the second preceding element, so it's going to be calling itself again, but the n minus 2, which is the second preceding element. And we just return the sum of them, I plus j. So yeah, I think that would be the solution. Let's just run it and see if everything is okay. Oh, sorry. Yeah. Yeah, it passes like all the cases. Let's submit it just to see if it works. Again, this is not the optimal solution because we're not storing yeah, it's good in memory, but it's as a runtime, it's not that good. But I mean, it's good to also say that let's say like why are we calling this with n minus one and not just n? Because let's say if we want Fibonacci of 3 and we call this function here in this line, it's calling itself. So when we're in this line here, line 7, we're going to return to this function and run this function given these parameters. So if this parameter is 3, for example, we want to get the third Fibonacci number, we would be calling itself repeatedly forever. It's going to be an infinite loop because Fibonacci of 3 is not going to be 0 or 1. So when we get to this line, we're going to want to try to calculate Fibonacci of 3 again. And it's going to go to the top here. Oh, is it greater or equal than 1? No. Okay, let's try to calculate Fibonacci of 3. And then. So that's why we use n minus 1 here and n minus 2 here. Um, yeah, that's one way of using recursion to get the nth number of a Fibonacci sequence. And this is also a shout out to Mateus Pimenta, my friend, who's doing his master in mathematics, and his thesis is all about Fibonacci numbers and so on. So shout out for you, my friend. And yeah, that's it.